We shall now be considering some other sample problems for Module 2, the Rankine's active. Next problem, a 5-meter high retaining wall is shown. Determine letter A, the Rankine active force per unit length of the wall and the location of the resultant. And letter B, the Rankine passive force per unit length of the wall and the location of the resultant. So we have here a soil and a retaining wall with a height of 5 meters, and the soil is a normally consolidated sand. So definitely this is a cohesionless soil. So C prime is equal to 0. And then the unit weight of the sand is 14 kilonewton per cubic meter. And the angle of friction is equal to 30 degrees. Let's begin by the first record, that is the Rankine's passive force per unit length and the resultant, or where is the resultant acting. So first, we have to solve for the coefficient of the active earth pressure, designated as case of A, with the use of this equation. So active coefficient of active earth pressure is equal to tangent squared multiplied by the quantity 45 minus the angle of friction divided by 2. So since the angle of friction is given to be 30 degrees, we can simply substitute that, and we come up with a value of 1/3 or 0.3333. After solving for the coefficient of the active earth pressure, we can now proceed to solve for the active earth pressure. So again, we shall be presenting our solution in a tabulated form. And on the first column, we have the depth. The second column, we have the vertical stress. The third column is the coefficient of the active earth pressure. And the last column is simply the active earth pressure. So at z is equal to 0, so obviously, we do not have a value for vertical stress, and we do not have also a surcharge load, so vertical effective stress is also 0. And then at a depth of 5 meters, the vertical effective stress is simply the unit weight of the soil multiplied by the height. So that becomes 14 times 14 kilonewton per cubic meter times 5 meters. Vertical effective stress becomes 70 kilonewton per meter squared. And then for the coefficient of the active earth pressure, we were able to solve this a while back. So we place here the value that is both 1/3. And then finally, we can now solve for the active earth pressure using this equation. But again, since our soil is cohesionless, if we substitute the value of C here, which is 0, definitely this term will be eliminated and we are left with just this term. So in short, if the soil is cohesionless, the active earth pressure is simply equal to the vertical stress multiplied by the coefficient of active earth pressure. So at Z is equal to 0, the active earth pressure is 0, and at Z is equal to 5 meters, the active earth pressure is simply 70 times 1/3, and that is 23.333 kilonewton per meter squared. So at this point, we can now plot our pressure diagram. So at Z is equal to 0, the value of the earth pressure is also 0, and at a depth of 5 meters, the value of the active earth pressure is 23.333 kilonewton per meter squared. So from here, we can now solve the active force unit length, and we have said that the active force unit length is simply the area of the pressure diagram. So the area of this triangle is simply 1/2 times the base times the length, so that becomes 1/2 times 23.333 times the height, which is 5 meters. So the active force unit length is 58.333 kilonewton per meter, and this is now our answer. So next is, where is the resultant acting? So since we only have one pressure diagram and it is triangle, we know that the resultant is always acting at 1/3 of the triangle from this reference point. So bars of z becomes 5 meters divided by 3, or that is simply 1.667 meters. So the resultant is acting 1.667 meters from the bottom of the wall. So if we are to plot this is our force per unit length, which is 58.333 kilonewton per meter, acting at 1.667 from the bottom of the wall. Next, we will now be determining the passive force and also where is the resultant acting. So we follow the same procedure. First is we determine the coefficient of passive earth pressure. So since we are determining the passive force, then the coefficient that we are to use should also be the coefficient of the passive earth pressure. So using this equation, tangent squared multiplied by the quantity 45 plus the angle of friction divided by 2, and the angle of friction is given to be 30 degrees. The value of coefficient of passive earth pressure is 3. Next, we can now determine the passive earth pressure, and we will be tabulating as well our answer. And the vertical effective stress doesn't change, so we carry on with the values that we had a while back. So at z is equal to 0, the vertical effective stress is 0. And at z is equal to 5 meters, the vertical effective stress is 70 kilonewton per meter squared. And then we were able to solve the value of the coefficient of the passive earth pressure to be 3. And then finally, we can now solve for the passive earth pressure using this equation. Again, our soil is cohesionless, so C is equal to 0. Therefore, this term will be eliminated. And the passive earth pressure is simply the vertical effective stress multiplied by the coefficient of passive earth pressure. So at Z is equal to 0, 0 times 3 is 0. And then at a depth of 5 meters, that simply becomes 70 times 3. So this is 210 kilonewton per meter squared. At this point, we can now plot our pressure diagram for the passive earth pressure. And again, at Z is equal to 0, the value is 0. And at a depth of 5 meters, the value is 210 kilonewton per meter squared. So our pressure diagram is a triangle, and we can now solve for the passive force per unit length, which is the area of this pressure diagram. So area is 1/2 times the base, which is 210, multiplied by the height, which is 5 meters. So the passive force per unit length is equal to 525 kilonewton per meter. This is now the answer. And then next is same as the active earth pressure. The resultant will be acting at 5 divided by 3, 5 meters divided by 3, or 1/3 of the height of the triangle. So this is 1.667 from the bottom of the wall, and this is our answer.